Okay, this is a review for the problems out of the textbook on page 242. I wanted to create a review video for those of you who had a little trouble with some of these problems, especially with the assessments in Google Classroom right now. So let's start with number 20. On page 242, so you had 8 problems to do, and number 20 was the first one. Now, even though number 20 looks weird, even though number 20 seems to be missing a term, the C term actually, you can still go through it with the Tucker method. Now, the Tucker method, again, those 5 steps being GCF, A times C, magic numbers, T-chart and simplify, writing the factored form. The first step, GCF. Both of these terms, 40 and 32, they seemingly have a number in common. Yes, you can divide an 8 out of both of them. But all the terms also have a variable. Now, this only happens when that C value is gone. There's no C value sitting there. So you can divide both terms by the variable A as well. If you divide both terms by an 8A, 40 divided by 8 would be 5. A squared divided by A would leave you with an A. Minus 32 divided by 8 is 4. A divided by A cancel each other out. This is all that you can do with the problem. The purpose of the Tucker method was to factor quadratics. And when you take out that GCF out of those two terms, you don't have quadratic anymore. 5A minus 4 is now linear. You also had to do number 26. Now, number 26 was one of those full quadratics, x squared plus 13x plus 40. Now, this is a 1x squared, so I don't really have to worry too much about the T-chart or anything like that, but I am still going to show it to you. GCF for this problem is a 1. 1, 13, and 40 have nothing in common other than 1, and only 2 of the terms have a variable in them. You would only take out a variable as a GCF if all the terms had that variable. So A times C is 40. Now my 2 magic numbers, I got to think of 2 numbers that multiply to 40 and at the same time add up to 13. If you kind of messed around with the calculator for a little bit, you'd be able to figure out that 8 and 5 are indeed those numbers. 8 times 5, 8 plus 5. Now, I did say that a T-chart was not necessary for this problem, but I'm still going to show it to you. Here's the reason why it's not necessary. Typically, in the top of the T-chart, you would write whatever this number is and the variable. Not the variable squared, as some of you did on that homework. You don't have to worry about the square because you're breaking it down. This would be a 1x and a 1x in the T-chart. Then you would have to simplify. But 1 over 8 and 1 over 5 don't simplify as fractions. And since they don't, vertically, I'll move that up a little bit, vertically, you're getting an x plus 8 and an x plus 5. Now, for numbers 20, 26, and 29, all the problem wanted you to do was factor. You did not have to solve these problems. The directions just said to factor. Not to mention they were not equations. They were just expressions. But let's take a look at number 29. Number 29, a lot of people ended up tripping up on or utilizing some online website to kind of help them get it done for them. But again, eventually, if you're going to have to do this for me in class, you're going to have to know how to do this on your own. 15x squared plus 7x minus 2. They don't all have a variable in common. And 15, 7, and 2 only have a 1 in common as a greatest common factor. So you don't have to worry about that. Move on to step number 2. Step number 2, A times C would be 15 times negative 2 to get negative 30. Again, you're trying to find magic numbers. Magic numbers that multiply to negative 30 and at the exact same moment add up to 7. Now, you could think of a whole different slew of numbers. I'm thinking like, okay, 30. I could do 5 and 6, but unfortunately, if one of them were negative, that wouldn't add up to 7. I could do, 15 and 2, but again, it would not work. 10 and 3 are the numbers you're looking for. Now, they have to multiply to a negative, so one of them has to be negative. In this case, the 3 has to be negative because the two numbers also have to add up to positive 7. Now, here is where you definitely need a t-chart. 10 and negative 3 go on the bottom of that t-chart. But in the top of that t-chart, it's a 15x squared, so I'm going to write 15x and 15x. Now, something is going to simplify here, but temporarily, I'm going to write 15x and 15x in both of those spots. Now, again, when I say simplify, I'm referring to the fraction. 15 over 10 reduces to 3 over 2. Now it's no longer a 15x, it's 3x. I'll write that in a moment. I also have to reduce this, 15 over negative 3. Now keep the negative on the bottom. But if you reduce 15 over negative 3, keeping the negative on the bottom, it becomes 5 over negative 1. You do have to have that 1 down there when that 3 cancels. Vertically, right here, I'm left with a 3x plus 2, and I'm left with a 5x minus 1. That is what these problems end up doing in terms of factoring. Oh, happy day. Now, for the remaining problems, you did have to solve, meaning you did have to get x by itself. You had to go a little bit farther than what those original problems were asking for. Number 39 gave you, I'll write this down, number 39, gave you x squared minus 5x minus 24 equals 0. Now that problem already was equal to 0, so you don't have to change anything there. But they wanted you to solve it. I'm going to go through the Tucker method again. This is a 1x squared, so I have a 1, a 5, and a 24. They all have a 1 in common, and they don't all have a variable in common. So a times c would give me negative 24. I would need two numbers that multiplied to negative 24, and at the exact same moment, they would add up to negative 5. 8 and 3 seem the best option, except that 8 has to be negative, because they have to add up to a negative 5. Now, again, I'm not going to write the t-chart for this one, because on the top of the t-chart would have been a 1x and a 1x. But since 1 over negative 8 and 1 over 3 don't simplify, it would become x minus 8 and x plus 3 as my factors. Now, mind you, this problem did want me to go a little bit farther. This problem did want me to take those two terms and solve them. So I would have to take x minus 8 equal to 0, x plus 3 equal to 0, and end up getting my two solutions. Oh, you can't see that. Sorry about that part. Ultimately, when you end up with the two factors being multiplied together equal to 0, you can set those individual terms equal to 0. It's the zero product property. As a reminder, if two things are being multiplied together and the result is 0, then one of those two things has to be 0. So right here, I have an x minus 8 times an x plus 3. Those are my two things. They're equal 0. So I can take the first thing, set it equal to 0, take the second thing, set it equal to 0. I get my two solutions. Let's take a look at number 41. Now 41 was just slightly different from the problem we just did. They wanted you to solve it. It was not equal to 0, so you're going to have to get it equal to 0. Subtract 17 from both sides. If you subtract 17 from both sides, you end up with something like that. Now I'm going to bypass a bunch of stuff right here. First of all, a times c is negative 4. There is no b value in the middle. I mean, technically the b value is a 0. Please keep that in mind, because I need to find those two numbers that multiply to -4 and add up to 0. Very quickly, a lot of you would be able to figure out it's 2 and -2. X plus 2, x minus 2 equals 0. Ultimately, my two answers, similar to what I had before, would be x equals -2, x equals +2. And both of them do indeed work. Number 42 was a bit trickier. In the directions that I left you when you did this assignment in the first place, in the directions, I left you the instruction to take out a GCF of -1. The reason being, as I've explained in class this past week, in a lot more detail, taking out that negative as your GCF makes your life 1,000 times easier. You want your A value to be positive. Now, besides the negative, 3, 10, 8, they only have a 1 in common. They don't all have a variable in common. -1 is what I'd like to do. When I take out that -1, it leaves me with the resulting quadratic. And again, it makes my life a lot easier. Once that -1 is out of there, I only have to focus on the quadratic that is inside the parentheses. So I'm left with A times C would be 3 times -8. And then I'd have to find my two magic numbers. Now, my two magic numbers have to multiply to -24, add up to 10. It shouldn't take that much digging to figure out that it really should be 12 and -2. They multiply to -24, they add up to +10. Now I got to go to my t-chart here. 12 and -2 are definitely in my t-chart on the bottom as my magic numbers. It's a 3x squared, so I got to break it up, 3x and 3x. Simplify. 3 over 12 becomes a 1 over 4. The 3 over 2, keep it. It doesn't simplify. Keep the negative on the bottom. This leaves me with a 1x plus 4 and a 3x minus 2 equals 0. Now, yes, technically that -1 is still there. And technically that -1 is still a factor. But you'll quickly see that that -1 does not play into my answer. I end up with 3x minus 2 equals 0. X plus 4 equals 0. And if you wanted to, you could write -1 equals 0, but that doesn't make any sense. So that actually would be crossed out if I decided to write that. -1 can't equal 0. Ultimately, I get two answers. -4 and the fraction 2/3, because you would have to add 2 and then divide by 3. Next were the two word problems. Well, word problems is really a picture, so I'm just going to draw this picture over here. For number 48, they told you that this side was 3x minus 4 feet, and this was x plus 2 feet, and the area on the inside was equal to 448 feet squared. Now, if you remember, the area of a rectangle is length times width. You would have to multiply length times width equals area. This is the proper setup to the problem. We spent this whole week working on word problems. Your project has a ton of word problems. You're going to have to properly decipher them. I need to multiply these two things together. And again, seeing the work, you can either do FOIL if you like it, or you could do a little box. I like the box. It makes me feel good. 3x minus 4 and x and 2. Multiplying together, 3x squared, -4x, 6x, and -8. This would get me the quadratic 3x squared plus 2x minus 8 equals 448. Now, it's a large number, but let's just see what happens. I got to get one side equal to 0. Ugh. If I do that, that would be minus 456 equals 0. Now, I put the cap on my pen because at this point, I got to go with the Tucker method. And with the Tucker method, oh my goodness, I'm going to have to take 3 times negative 456. It's going to give me a large number. The calculator is going to do most of this for you, as long as you know how to use it appropriately. 3 times negative 456 would give me negative 1368. Your job is to find 2 numbers that multiply to negative 1368 and at the exact same moment add up to positive 2. Now, it seems like a very daunting task. I know. But let's just see what happens when I decide to break some things apart. So I'm going to start with 1368. I'm going to ignore the negative temporarily. Let me just divide it by, 100. No, definitely not. The difference between those two numbers, 113 and change, that's nowhere close to 2. Let me go 1368 divided by, no, it's even farther away. 1368 divided by 50. Getting closer. 1368 divided by 40. We're getting closer. If you look at the 40 and the 32, they're only 6 apart. 1368 and 30. We're getting farther away. 1368 and 35. We're only 4 away. 1368 and 36. There they are. It doesn't take that much time to figure that out. It may seem like it takes forever, but in reality, that took me like less than 30 seconds. As long as you know what you're looking for. 2 numbers that multiply to negative 1368. One of them has to be negative. Thus, they have to add up, in this case, to positive 2. So, I'm going to continue this problem right here. Move this up a little bit. A times C gave me negative 1368, and the 2 magic numbers that I found were 38 and 36, but the 36 had to be negative because they had to add up to positive 2. I'm going to go with T-chart, 38 and negative 36. It's a 3x and a 3x. I got to simplify. This becomes a 1. This becomes a 12, or a negative 12, really, because that negative stays on the bottom. The other one doesn't simplify. I end up with 3x plus 38 and an x minus 12 equals 0. Now, as you've seen before in the past, you set each of these terms equal to 0 and solve. However, this problem, if you were to solve it, would give you a negative answer, a negative 38 over 3, which if you plugged that back into the original rectangle, would give you a negative length. It's not because the answer is negative, it's because when you plug it back into the original rectangle, it results in a negative length. X equals 12 seemingly is the answer I'm looking for. Before I actually circle that answer and confirm it, a good practice would be double checking to make sure that I'm right. If the answer is 12, because the problem did want my dimensions, one side would be 14, and the other side would be 32. 14 times 32 does give me that appropriate area. 14 and 32. Interesting. So now x equals 12 is indeed the answer I'm looking for. They wanted me to find x, but they also wanted me to find the dimensions of the rectangle. And according to the calculations that I did, it looks like 14 feet by 32 feet. All I did was plug that 12 in back into the original rectangle to get the length and the width. Finally, I also had you do number 69 in the textbook. Number 69 was a little bit different, obviously, because you had a triangle. This is just a terrible sketch of that triangle. Terrible sketch. In which they tell you the height of that triangle is x minus 2, and the base of that triangle is x plus 7. They also tell you that the area of that triangle is 26 square centimeters. Now, if you remember geometry, the area of a triangle is nothing more than 1/2 base times height. A lot of people forgot that 1/2. 1/2 base times height equals area. This is the proper setup to the problem. Now, solving this using everything that we've been doing, there is a little trick that I kept telling people. You see that 1/2? I would like to get rid of it, and I don't want to distribute it. So instead, I'm going to multiply both sides of the equation by 2. If I multiply the left side of the equation by 2 and the right side of the equation by 2, the terms on the left cancel, leaving me with x plus 7 times x minus 2, which I'm going to have to multiply together in a moment, equals 52. Let me just very quickly multiply these two together. x7, x negative 2, x squared, 7x, negative 2x, negative 14. This leaves me with x squared plus 5x minus 14 equals 52. That's the quadratic I have to solve. If I subtract the 52, let's see what happens. I get minus 66 equals 0. Now, again, kind of bypassing the Tucker method a little bit, two numbers that multiply to negative 66 seemingly are 11 and 6, but one of them has to be negative. If one of them is negative between 11 and 6, the 6 has to be negative because they have to add up to the positive 5. They have to add up to the positive 5. Solving this gets you two answers, negative 11 and positive 6. Now again, just because the 11 is negative does not mean that it is disqualified. The reason why the negative 11 is disqualified is because when you try to plug it in back here, it gives you a negative length. 6 has to be the x value. Now, 6 is not my final answer because the question wanted find the length of the base. If you plug that 6 back into the base of x plus 7, you get a base of 13 centimeters. If you wanted to, you could also talk about the height, even though it didn't ask you for it. You get 4 centimeters when you plug that 6 back in. And again, 1/2 base times height. 13 times 4 is 52, times 1/2 is 26. I hope that looking at these problems, me reviewing these problems with you, is helpful, especially with the assessments that you guys are going to be doing for me and the project that you are going to be finishing for me. If you have any other questions, please make sure you are contacting me. Thank you.